As posted, I decided in the morning to go live showing various aspects of resistors in a live program, and we start now. Maybe very few will join because of timings, I do not know, but all are requested, if interested, can visit the live program later on. What I am showing today is a lamp glowing, and make the light up so that you can see better. This lamp is controlled by this setup, and this setup is a variable resistor. I make a zoom and you can see it has got 3 terminals, one at this point, one at this point, and one floating terminal here. What is the idea right here? If you provide suppose 15 volt, your lamp will not get 15 volt directly. This device will consume, say for example 8 volt, and remaining 7 volt will be coming to this lamp. So, the lamp glows faint. Now, as this floating terminal will be moved this way, you will find the glow of the lamp will be reduced further. I make a zoom again. You can see when I move, this end it will be more, and moving this way will be getting lower voltage for the lamp. So, it is getting dim. So, this is a type of resistor, it is comprising of a wire which controls the voltage and current also. So, next this is called a variable resistor. This is widely used in our school and college labs, because children will be controlling voltage using this for their load purposes. Generally, we do not have it in our homes for home lab, but I find it is necessary, because if you want to furnish a lab, you must have everything. And then I switch over to one more common resistor. I will show you again after disconnecting this. Suppose here is a resistor, this is called a fixed value resistor, but wire wound. So, what I am doing, I am connecting this with this. So, for example, current comes here, and then it will out be here. So, at that out point, let me keep my lamp, and you see the glow of the lamp is better than this place than the previous resistor. So, what I want to do now, I want to reduce the voltage little bit and show you that the supply voltage is reduced suppose, and this also controls to a particular level. So, this is called a fixed resistor, and they are of different wattage. This watt is 5 watt. And now, we come to electronic board resistors. These are all fixed value resistors, and they are called carbon resistors, and they do have some color codes to find out their values, but please make sure that this lamp is a auto lamp and they draw more current. So, they cannot be regulated by these resistors. Now, for their regulation, we have to again use a breadboard and LED and other connections. Say for example, we connect LED, you just see how we control the glow of the LED. Suppose your supply voltage is 6 and you want to control with a resistor, and now we are having a resistor here. Suppose we connect it here and then we drop it at another point where you have to provide your power. Say for example, I make a zoom and show you how is the connection. This resistor is connected to the LED and we will provide power here only, and negative wire will be here at this end. And I told the other program this LED has got a positive end and a negative end. So, you have to ensure accordingly. Say for example, if you drop it here over these two terminals, right, I give you more light rather, that will be better. This I further zoom, the resistor and the LED legs are common on a particular slot, and then the green wire will be connected to the negative terminal, and here will be our negative of the source. Say for example, this is my negative terminal, I connect here, and then for the positive I have to use, as I told, this particular point because the resistor starts there itself. So, let us see, we do not know the value of the resistor, but if we provide the power, and I will show you with what voltage actually it will glow. Say for example, this is already loaded to power and I provide power, and you just see we will measure voltage. Let us start from a standard, switch off the lights, they are more in our case. Now, we have to verify that the LED gets a standard voltage for its glowing. So, I keep it here, I remove it and I keep it here for your observation. I make further zoom and you can see I think better. And as far as multimeter is concerned, I do have a multimeter here with me, and I will measure and I will just show you the reading, what is the voltage of the LED with this resistor and what is supply voltage. Let us measure first the supply voltage, and supply voltage will be measured directly across the terminals. What my meter says, this is 7.9, I can show you even if I measure it, this is 7.9 or 8, 7.9 or 8, something like that. It is not a big difference. Now, what voltage the LED is getting, let me confirm you. This is just 1.63. So, please see the supply voltage is 9, suppose 8, not 9, 8, and LED gets 1.63. That means, we will increase voltage one more step. Let me show you again that this time the supply voltage is 10.5 and LED gets I show you again, LED gets 1.65. You can increase one more step, because you know your LED standard voltage is 2.2 for red LED. You see the glow of the LED is increasing. I show you again the measurement. The input voltage is now 12.45. So, this is a pretty high voltage for LED, but see, using this resistor we have easily controlled the LED, because LED gets 1.66, which is even below the normal range. I can increase one more step from my power. I have increased again one step. I will show you again what is the supply voltage now. The supply voltage has increased to 16.45. You can see measurement shows. I give you the correct reading. So, this is very important for all of us to check whether we measure it perfectly or not. I repeatedly show you the supply voltage has increased to 16.5, but LED gets only 1.68. So, this is a good regulation, you know, that means if LED gets 1.66 out of 16, that means this resistor drops 15 volt, and that I have to confirm you. So, this resistance is important for us in that sense, because it controls the rest of the voltage, and this is 15 almost. So, as I said, if the source voltage is 16.5 and this is getting 1.5, that means the rest of the voltage is being utilized here, and if I contact my finger here, I will feel slight heat, because this heat produced over a resistor depends upon the current the load is drawing. So, here the LED is drawing only 20 milliampere current, but if I connect this lamp to this resistor will be burnt, because this is drawing suppose 1 ampere current, then this is not designed to bear 1 ampere current, this is designed to bear some milliampere current. So, this is widely used in electronic boards and electronic gadgets, not on power electronics. This is called a electrical component, not a electronic component, but I utilize it to show you this item. So, what I committed, I will show you today various aspects of resistor. I showed you, I will summarize because I have to close by 11:45. This is a variable resistor. They see these are the wires and they control the current and voltage. As it is written, you can see the total resistance is 50 ohms and ampere it can withstand is 1.6. So, let us have it in our home for measurement and all those things. And now, I have again shown this type of resistors are also used in power electronics, because they need to consume more current and more power, and this is why they are robust. Even though this is 10 watt, but it consumes almost 1 ampere or 2 ampere or current, something like that. And thereafter these resistors are of different size, because you know this is 1 watt resistor, and I show you one more, this is quarter watt, that means 1/4 watt of resistor. They also control these electronic components, and you know here is another, but you know their color code may differ. if they differ, then their values will differ. One value I will show you using multimeter. So, let me switch it off and then I will show you with the multimeter how we measure the ohm value of a particular resistor, whatever we have with us. See, this is in ohm value, you can see the regulator, and if I hold it both the ends, it is showing 1 kilo ohm. So, this is 1 kilo ohm, remember. And now, let us put this and verify what is this. This is 10 kilo ohm, this is 9.9. So, that even roughly this is 10 kilo ohm, and you know that is why this is 10 times dropping than this, and I do not know exactly what is this, but the color code will describe the value, but we measure it here with our multimeter, not by color code. If I place, I have already told you this is 1 watt resistor, this is also 10 K. So, the color code for the 10 K, you remember here you see by your eye through camera, this is one is brown, then the other one is black, and the third color band is orange, that means brown represents 1, black represents 0, and you know the orange is a multiplier, that means 3 0 to be put together by the side of 10. Why 10? Brown stands for 1, black stands for 0. So, they form 1 and 0, and thereafter orange means 3 0 after 10, that means 10,000 ohm. So, this is 10 kilo ohm. So, this is a very important for all of us to know these things before we study the basic electronics, because you know electronics is very interesting for all of us. Maybe you go for software, it is not a matter, but basic electronics is a must for everybody. So, with this I come to the end of this today's program live, and I do not know how many have joined, but if you have some questions you may write. Let me see. Okay, with this I come to an end. We meet as per publication next.